All right, let's dive in. You know that feeling when you're picturing your route to work or trying to mentally rotate a piece of furniture before you move it?
Uh-huh.
That's your mind's eye, right? Well, what if I told you researchers are exploring whether AI, specifically large language models, might be developing something similar? Crazy, huh?
Yeah, it's a really fascinating area of research,
Mhm.
and it's not as sci-fi as it sounds. This paper we're looking at, Mind's Eye of LLMs, visualization of thought elicits spatial reasoning in large language models. It suggests that LLMs might be on their way to actually developing this mind's eye. And get this, all through text.
So we're not talking fancy graphics or visual input. It's like they're building a mental model of space, but their building blocks are words.
Exactly.
So this deep dive is all about how they're trying to make this happen and what it could mean for, for the future of AI.
Right. I mean, just imagine the possibilities.
Yeah.
Robots navigating crazy environments, self-driving cars that really get their surroundings,
Mm.
even AI that can design stuff, complicated objects,
Yeah.
or even grasp like really abstract concepts. It all comes down to this ability to see space, to reason about it.
Okay, before we get too far ahead of ourselves,
Sure.
let's break down what spatial reasoning actually means when we talk about AI.
Okay, so it's basically the ability to understand where things are in space,
Right.
like how objects relate to each other,
Hmm.
distances, directions, how to get from point A to point B.
Mm.
Imagine you're navigating a city.
Yeah.
You need to know the coffee shop is across the street from the bookstore, that
Yeah.
the park is 3 blocks west,
Right.
that kind of thing.
So it's more than just knowing spatial words like left, right, above.
Right.
It's got to actually grasp the relationships to actually solve problems, make decisions.
Yeah, precisely. And that's what makes it such a challenge for AI. It's not enough to just recognize the words. They need to understand the concept.
Which brings us back to this mind's eye idea. We humans, we just do it, no problem.
Yeah.
Is it even possible for LLMs to develop this?
Well, researchers think it might be. They're using this technique. It's called visualization of thought, VOT for short.
Voti? Okay, so are we giving AI a mental whiteboard?
Uh-huh. That's a good way to think about it.
Hmm.
Basically, instead of just spitting out an answer, the LLM has to describe what it's seeing, but with words after each step of the reasoning process.
Okay.
So let's say the LLM gets the instruction, go 1 square up, then 2 squares right. With VOT, it might say something like, I'm at location, 2. North is a wall, east is open space.
Ah, got it.
What's your-
So it's not actually making an image.
Right.
It's describing what it's seeing in its mind.
Yeah, exactly. And the researchers wanted to know, can this internal process of visualizing, but through language, lead to better spatial reasoning?
So how do we put this mind's eye to the test? Game time for the LLMs.
Right. They designed 3 spatial reasoning challenges, each one tougher than the last. First up, natural language navigation.
Okay.
The LLM has to follow directions in plain language, like navigating a 3x3 grid. Instructions like go up, then right, then down.
So it's like a word problem, but the LLM actually has to build a mental map to get it right, not just repeat the words.
Exactly. Now, for the second challenge, visual navigation,
Uh-oh, getting harder.
they upped the game. Gave the LLMs a visual map, but not an actual picture. Think of it like a map made out of special characters.
Interesting.
Almost like a super simplified text-based version of, like a map on your phone.
So instead of streets and buildings, it's symbols and characters.
Right. And they had to do 2 things. 1, plan a route from start to finish, dodging obstacles.
Got it.
And 2, predict the next step on a route that's already partly done.
I can see how that would take some serious spatial skills.
Mm-hmm.
Okay, so what was the ultimate challenge?
The third one was visual tiling. Think those classic polyomino puzzles where you fit shapes into a grid?
Oh, yeah.
They use the eye tetromino, the one shaped like a straight line of 4 squares. The LLM is given the grid, the shape, and has to figure out how to rotate it, position it to make it fit.
Whoa, so no more moving around a map. Now it's like playing Tetris with text. It's got to visualize these shapes, rotate them, fit them into this specific space.
Yeah.
Okay, time for the big reveal. Did these LLMs actually show signs of a mind's eye while tackling these spatial puzzles?
The results, well, let's just say they were pretty darn interesting. We'll dive into those after the break. So we're back and ready to unpack these results.
I'm still kind of mind blown by this whole idea that AI could see spatially, just with words.
It is pretty wild, and this research is really pushing the limits of what we thought AI could do.
We left off with those 3 spatial challenges: navigating the grid, planning routes on that symbolic map, and then solving those tiling puzzles.
Right.
So what the researchers find, did those LLMs actually show any signs of a mind's eye with this visualization of thought thing?
This is where things get exciting. Across all three challenges, the LLMs that used VOT, they performed way better than the ones that didn't. It seems that prompting them to, describe their visual state at each step really helped them solve these spatial problems.
So they were better at navigating, planning, and figuring out the shapes when they had to say out loud what they were seeing step by step.
Yeah,
Wow, that's pretty amazing.
it is. And there's more. In the visual tasks, get this, the LLMs with VOT, they actually beat a multimodal LLM that had actual images as input.
Hold on, wait. So they're only working with text, but they built a better mental model of the space than an AI that could actually see the images? How is that even possible?
It suggests that putting their thoughts into words, that process, somehow strengthens their spatial understanding. It's like they're externalizing the reasoning, making it more concrete and effective.
You know, it's funny. Sometimes when I'm stuck on a problem, just talking it out helps me see the solution,
Right.
even if the person I'm talking to has no idea what I'm on about.
Exactly. It's like your brain organizes the info in a way that makes sense,
Huh.
visually and logically. And that seems to be what's happening with these LLMs.
It's like they're narrating their own mental map, even if no one's listening but themselves.
Yeah, and it really makes us rethink how intelligence works.
Yep.
We used to think language and vision were totally separate. But this research, it hints that they might be more connected than we realized.
So maybe language is like a more fundamental building block for spatial reasoning than we thought, even without any actual visuals.
It's a fascinating idea, and it could totally change how we develop AI. Instead of just focusing on making AI see like us, maybe we should look at their language abilities, see where that leads.
It's like we're unlocking this hidden power in language, the power to represent and understand the world in ways we never imagined.
Exactly. And if LLMs can develop this mind's eye for space, what other human-like abilities could they have? Could they eventually grasp, time or causality, even emotions?
Whoa, okay, now that's some next level stuff, but let's not get carried away. The researchers did say that VOT isn't like a magic solution. It didn't work for everything. And those LLMs still struggled with the really complex problems.
That's true. VOT seems to work best for tasks that need a real understanding of spatial relationships, not just following rules or, moving symbols around. There's a limit to how well they can do, for now at least.
So their mind's eye, it's promising, but still a work in progress. What were some of the challenges the researchers hit while they were trying to, cultivate the spatial reasoning in LLMs?
One of the biggest things was getting those LLMs to make visualizations that were consistent,
Yeah.
and accurate. Remember, we're talking text descriptions, not pictures. So the LLM has to choose the right words, the right symbols to express what it's seeing.
It's like trying to describe a Tweety object to someone who's never seen it. You got to be super precise, and even then, it's tough to get the full picture across. And the LLMs, they don't have our human experience with these concepts.
Exactly. They're learning about space purely through language, which can lead to, some quirks.
Mm.
Sometimes the descriptions were incomplete or inaccurate, sometimes even contradictory.
It's like they're trying to build a puzzle without the picture on the box. They're figuring it out piece by piece, but missing some key parts.
That's a great way to put it. But, it highlights how much progress they've made despite these hurdles. It's amazing how these LLMs can learn and adapt.
Makes you wonder, will those visualizations get better, more consistent as the LLMs evolve? Imagine, with more data, better training, their mind's eye gets even sharper. What could that mean for their understanding of the world, not just space, but everything?
It's a really exciting thought. And it leads to some big questions about what all this means for AI, the good and the potentially not so good.
Okay, now we're getting into some deep stuff. Let's save that for the last part of our deep dive. Okay, so here we are, the final part of our deep dive into the mind's eye of LLMs. It's been pretty wild, right? Exploring how AI might be learning to see space, just using language.
Yeah, we've covered a lot. Spatial reasoning, that visualization of thought technique, those crazy results.
I'm still kind of reeling from that whole thing about LLMs, with VOT beating the AI that had actual images. It really makes you think about intelligence, both human and artificial, in a different way.
Definitely. And it brings up so many questions, especially when we think about LLMs having a mind's eye. It's not just about, robots and self-driving cars anymore. It's about, what does it even mean to be intelligent,
Oh,
to perceive the world?
it's almost like philosophical, right? If a machine can learn to see space just with words, what else could it be capable of? And how do we as a society make sure those abilities are used, for good?
These are the big questions. and they're not easy to answer. We're in uncharted territory, really, but we got to talk about it now before this tech gets even more advanced.
Right, right. It's easy to get caught up in the excitement, but we can't forget the potential downsides. It's a huge responsibility, and it's not just on the tech folks. It affects all of us.
Absolutely. Think about the possibilities, though. Imagine AI architects designing buildings that perfectly fit their environment, AI doctors diagnosing diseases with incredible accuracy, AI artists creating stuff that blows our minds. These are just a few examples of what might be possible.
That's a pretty amazing future. But like you said, there are risks. What if this tech gets into the wrong hands? Could it be used for, like, surveillance? Or even manipulation?
Those are very real concerns. With any powerful tech, there's always the chance of misuse. That's why we need ethical guidelines to make sure AI is developed and used for good for everyone.
That makes me think, who gets to decide how this tech is used? Governments, corporations, individuals. How do we make sure everyone has a say in the future of AI?
It's complicated for sure. We need open discussion, collaboration between policymakers, researchers, ethicists, and the public. We need to understand both the good and the bad and work together to make sure AI benefits us all.
Sounds like a big challenge, but I think we can do it. Humans have always found ways to use new tech for good throughout history.
We're adaptable, and we're good at innovating and solving problems. If we approach AI carefully, with ethics in mind, we can make sure it helps us, not hurts us.
Well said. This has been an incredible deep dive. Really got me thinking. We've just scratched the surface of something that's only going to get bigger and more important.
It's a conversation that's just starting, and we want all of you listening to keep exploring, keep questioning, and keep engaging with the world of AI. The future is being written now, and we all have a part to play in it.
So keep those minds curious, keep those questions coming, and until next time, keep diving deep.